So this one is our first cube, and our material decision was to take this bouncy balls, which is made out of the special polymer that wouldn't melt, and that was our first idea, to melt the bouncy balls. But then we decided to cut them, to fit them into 30 by 30 structure. And that's how we created the base. We put cut bouncy balls in halves and quarters and fitted them, arranged them in this way. And then the rest we filled in with another material, since we kind of ran out of the bouncy balls, and we decided to make these mountains in the corners and added this grid of wires to reinforce the whole structure and halves to complete the dimension together.
Okay, our second corruption is the bandwidth. It kind of doesn't look like the previous models, but when you see it closely, it's got the invisible pipe, which is we're trying to use the spring. So it's actually the wires are wrapped around the pipe and the springs are formed. The interesting thing is that spring is actually the formation of the circle, but we actually twisted to make it semicircle. But when you see from the side view, when the semicircle is actually overlapped, it becomes a circle. So this kind of model is just one part of this whole structure, and when you see from the above or side or bottom, it actually has the shape of the pipe. This is only 1/4 of the section. So when this whole thing is it's all seen together, it's actually there's 16 pipes going through it, this direction and that direction, and the layers are formed as well. So the interesting thing is that when you press from the middle, it only presses down to the middle. Press here, here, it can bend anywhere. So it doesn't break, it bends wherever it can be. It's a spring formed with in concept of three-dimensional, doesn't break, it always comes back to the original shape. Thank you.
Our second corruption was to make the box darker and to make a gallery inside and choose an art piece or a sculpture and make the perfect lighting for that art piece or sculpture. Instead, we decided to make our own art piece and a light sculpture inside the box. And we wanted to keep the same concept as the two boxes before this, of tension and the two pyramids. So we created different samples to see how light would react and how light would go through the holes that we perforated. And then we decided to use nylon strings and acrylic cords to make a structure inside with two pyramids and tension holding the box together. And now I'll show you the light sculpture inside the box.
Okay, so our second corruption was to make the cube as dense as water, so it could float, but not float, stay in the middle of the water for 1 minute. So we used foam for the mod of the first cube. So we decided to put foam inside the cube to achieve the same density as water. And first we did a test, putting the foam inside the little cubes, and we calculated the right amount of foam that we need. That is around half of the volume of the entire cube. And we tried to put it only stick on one side, so the cube would be stable and floating on the other side. And but we had problems casting it, so it came a little bit up and a little bit on the corner. So the cube was in the middle of the water, but one corner was touching the surface and one corner was touching the ground. And yes.
Okay, so this is our first corruption, which is hotter and colder. And the rationality of the design comes directly from our first cube, which is the layers and the supporting pipes. So the functionality is that the heat source will be placed in the middle and on the bottom. And you can see how the first two metal sheets will be connected, will be touching the pot itself, so that the heat can be transferred via conduction. Whereas the other sheets will be the layers of, you can see the layers of different heat. So it will be like a gradient. And so as it goes up, it gets colder. And this is because the first few layers won't be touching the pot itself, so it's all radiation. Another cool fact is that these pipes will be like the fur, in the air pockets in the fur of a polar bear, but instead of having just air, we decided to put cold water to serve as a contrast to the heat in the middle. So as you can see in our first thermal imaging, you can see that the temperature is negative 0.1 degrees Celsius, whereas in the middle it reaches up to 68 degrees Celsius. Also, one interesting property of metal is really cool because you can see how
Hi, the first corruption is lighter in terms of weight and light. So at the beginning we made some samples testing the shadow casting through different perforation of the MDF, as we had to make our cube lighter in terms of weight and perform 20% gray shadow at the wall. And after the testing process, we have done few models, and to avoid certain problems, we had to use beams which prevent the cube from bending in this direction and in this direction. We also used the same idea of the tension and we kept the same shape of two pyramids in the cube.
So for our last corruption, we had to make our cube quieter. We decided to keep the same material, of course, which is Perspex, but we did use the 5mm Perspex as well, because it's more easy to stop sound from exiting if you use two different thicknesses of material. So we had 3mm one, the outer cube, and then the inner three cubes are made out of 5mm Perspex. The Perspex alone made the cube quieter, but the problem that we had to deal with was vibrations. And for that we used silicon, so little pieces of silicon on the bottom one, and we used invisible tape to elevate the inner cubes, which prevented it from vibrating. So we managed to make our cube very, very quiet, especially at the 2000 megahertz. It is completely quiet.
So for the material corruption, we changed the texture of the cube. So we burned the polystyrene and we add wood sticks inside it in order to make the texture rougher. So we added weight on the box in order to make it to experiment how the weight would affect and to see if the cube would be rough. So here you can see a sample of the burned polystyrene with the wood sticks.
Okay, so then the first corruption was to go taller, at least 120. I think this one is more than 180. Actually, we copied the same concept. Obviously, it weighs exactly the same as the first one, and but now what makes this one interesting is that actually, whereas in the first cube the rubber doesn't really do that much, the cube gets its strength from the wood in general. Here, this one is actually a tower that is completely in balance with compression and tension, and it's actually quite stable, and it's really only held together by these ropes and like really thin wood parts. So, well, the natural aspect also comes into play where it is also visually perfectly in balance, because you can see how the compression and the tension are keeping each other into balance.
The first corruption was about twisting, and we started to create our idea from this. And you see that it's already twisted, and it should return in his initial position. So what we can see here. After that, we were trying to find some different solution for this, and but we realized that twisting here happens just in the middle, but not everywhere. And after that, we were trying to find some solution between these two examples, and that's our final cube. We twisted it a bit already. For two cases, it's statics, but at the same time, it's to make it more to make it return to his initial position. So it's like that, and we have special mechanism how to use it. So twist it for 56 degrees. 56, and after that, it will turn to its initial position. So it works. We didn't use glue here. We used just strings and cut it in a laser printer. That's some interaction between these two, because this one it's too heavy for when you're trying to make it in this scale, but at the same time this one it doesn't look like a cube because we choose not diagonal, but just so. This is our final decision.